Right, hi there everyone, my name is Hamza. I am a cybersecurity engineer at Cisco, and today we are going to cover IPsec. We're going to look at the protocol IPsec, Internet Protocol Security. And this is a protocol that concerns many security engineers but also network engineers. And today we're going to look at some fundamentals concerning it, particularly the tunnel formation. IPsec is a protocol that you could probably study a doctorate on. You could probably study a master's thesis on because of how in depth you can actually get with IPsec. However, our goal, our aim is to understand the protocol in a good amount of detail, in sufficient detail to exceeding the requirements of the CCNP certification, but also a little bit more just to understand how it fully works. So then when we're configuring it on routers and firewalls and whatnot, then we understand a little bit of what's going on and we're able to troubleshoot better. So let's start. So before we start, in fact we have started, IPsec is not a protocol, even though I might have referred to it as a protocol. It's actually a suite of protocols, and we look at what combination of protocols it uses or it can use. And it's used to provide secure communication over an insecure channel. So if we're going over the internet, we want to have a secure channel where I can send you a message, I can send you a photo of my kitten. I don't have a cat, but I'm just saying, I can send you a photo and no one else can see that photo, no one can change that photo, and I know that photo has arrived without someone having modified or looked at it. Its primary purpose is security over IP. So it's a protocol that works over another protocol, which is the IP protocol, in the internet protocol, and therefore it makes it a layer 3 protocol. So the IPsec is a layer 3 protocol. And that is because IP doesn't have any security, so IPsec is needed for when you want to send stuff with confidentiality, with integrity, and with authentication. So if you've ever studied the CIA triad, then if you haven't studied it, sorry, then now would be a good time to go revisit the CIA. Modus operandi. That just means modes of operation, but I like using that terminology because it sounds cool. IPsec has two modes of operation: tunnel mode and transport mode. Tunnel mode is when you want to encrypt the whole IP packet, basically the payload and also the source and destination information. And when you use tunnel mode, you've got to add another header on, a new IP header. But transport mode is just encrypting the payload data. So like if I send you an image, or if I send you a, yeah, let's just go with that example, I'll send you an image, it's just a payload data. So the source and destination IP address will still be able to be viewed by anyone that, that sniffs that packet. And then we have IPsec protocol, which sometimes gets confusing because you're like, what does that mean? I like to call it an encapsulation protocol or encapsulation framework protocol. So this is how the IP packet is going to look once IPsec has done its job. And there are two protocols that IPsec uses: ESP, the encapsulation security protocol, and authentication header. The authentication header only provides authentication and integrity to the packet, the packets that are flowing between the site to site. On the other hand, encapsulating security protocol will provide integrity, authentication, but also encryption. So there are certain situations which you may not want to use encryption, but you may still want authentication and integrity, and that's what that's used for. Although authentication header is kind of redundant because it's not often used, because ESP, does integrity, does authentication and of course encryption. So let's move on. So I just want to make clear some terminology as I will be speaking about IPsec. The initiator. When I say initiator, I'm referring to the device, the networking device that starts the connection, that wants to send something, and the responder is one that obviously responds. And then also want to make one more thing clear, that the initiator, I'll be referring to a site-to-site connection. So that's a branch here, and maybe a headquarters here, or another branch here, and another branch here. So yeah, just want to make that clear. Just before I start, actually, I just want to mention that this video is going to go into some good detail, so be prepared. And I haven't scripted this video, so I might be stuttering here and there. But if you really want to learn something, this is the only way. It's a long video format. It's not reading, watching a short, or just reading for 3 minutes. You're not going to learn. You're not going to actually. If you want to fully learn what IPsec is, then I recommend that you watch this video as a good intro, as a good start to IPsec. So, the life of an IPsec tunnel. So the phases to IPsec tunnel formation are just IKE Phase 1 and Phase 2. However, just to show you where it fits in the life of an IPsec tunnel. So, initiation, when something must trigger the creation of a tunnel. Of course, it's not going to be you manually sitting on that device, when someone wants to send traffic, you're going to say enable the enable IPsec tunnel. It's something that's going to trigger it. So it might be an access control list to start the IKE process. Then we have IKE Phase 1 and Phase 2, which you can have a read, but we're going to delve into more detail in these two components. And then, of course, once IKE Phase 2 is complete, your data can now be sent through the IKE Phase 2 tunnel, and of course, your data will be authenticated, integrity, and optionally encryption if you've chose a suitable method that offers encryption. And then termination, obviously that's when you strip down the tunnel. So let's have a look at now IPsec tunnel formation. So before we dig deep in IKE Phase 1 and IKE Phase 2, let's have a look at a summary of the two phases. So IKE Phase 1 is used for management data. The purpose of Phase 1 is to establish a tunnel that we can use to build IKE Phase 2. So if you look at this image that I borrowed from Cisco, it actually summarizes it quite well. The ISACamp tunnel, don't get confused by the naming. Sometimes they call the IKE Phase 1 the ISAKMP tunnel, and then Phase 2 is called the IPsec tunnel. And IPsec tunnel forms within the IKE Phase 1 tunnel. So the IKE Phase 2 tunnel is the one that's actually protecting the user data. Ignore that, we'll be looking at this in a few minutes. So let's start by looking at, in more detail, the IKE Phase 1, the ISAKMP tunnel, if that's how you pronounce it. Okay, so now let's have a look at the IKE Phase 1. And one thing to bear in mind is that the IKE Phase 1 is sometimes called, oopsie daisies, is sometimes called the slow and heavy phase, and that's because it takes longer to establish than IKE Phase 2. So just some things to summarize that will help your understanding when we're studying it in more detail. IKE Phase 1 is called the protocol Internet Key Exchange. So it's a protocol for essentially how keys are exchanged, but it does a few more things and sets some parameters. IKE Phase 1 is only used for management traffic to establish IKE Phase 2, as we've mentioned, and it's the slower and heavier part of the process, and here's what occurs. So obviously we've got the agreement of the parameters for the security association, and we'll take a look at that. In the IKE Phase 1, you actually are establishing the asymmetric keys, which are used, you're establishing the symmetric key from the asymmetric keys, and then authentication occurs using pre-shared keys or certificate. The end result of IKE Phase 1 is a tunnel, a Phase 1 tunnel. So let's take a look at that tunnel. So here's the tunnel. There are 6 messages in the IKE Phase 1 tunnel between the initiator and the responder. Only the last 2 messages are encrypted, as you can see here, only the last 2. And that's because encryption, the key for symmetric encryption, finishes at the end of message 4, which is this one here. There are 2 modes, aggressive mode and normal mode. Normal mode is the one we're going to be looking at today. Aggressive mode it shortens the number of messages that happen in IKE Phase 1, but we're not going to take a look at that today. So I've broken this down into 3 steps, into 3 stages, just to make it easier. So 6 messages, I've broken it down into 3 steps. Step 1, negotiation. The initiator will propose a negotiation about the following item. So he will say, for hashing, so these things in blue, for hashing, I'd like to use MD5. For authentication, I'd like to use a pre-shared key. You can use a pre-shared key or a digital certificate. Now, obviously the digital certificate is going to be more secure, but for the example, let's say he sets the pre-shared key as password 123. Now, password 123 is going to have to be manually configured on the initiator and the responder. The DH group, the DH group is Diffie-Hellman group, is essentially it's used to create the Diffie-Hellman key, to create the symmetric key on both sides. The higher that you set this, the higher the DH group, obviously the strength of the key, the higher the strength of the key used, and that means more secure, but also means it's more taxing on CPU. It's more taxing on CPU. Lifetime. So how long should the IKE Phase 1 tunnel live? And by default, the shorter, the more secure it is. And the default is actually 1 day. The encryption algorithm. So what encryption should we use for the IKE Phase 1? So this is not talking about the IPsec tunnel. It's only talking about the encryption for IKE Phase 1. And the options for that are DES, 3DES, and advanced and AES, and advanced encryption standard. Obviously, the most secure of them is the AES. If the responder has matching values, both the initiator and responder will agree on all the above. And if they agree, then we can move on to step 2. I forgot about this slide. So the result of step 1 is the result of negotiation is a security association. That rhymes. And a security association represents a unidirectional set of security parameters and keys in the tunnel between the two network entities. So the security association is basically all things like what algorithms were used, what's the lifetime, what's the security keys that we established, what's the destination address, what mode, and it's characterized and identified by what's called an SPI, the Security Parameter Index. So just know what it is so far. It actually becomes quite handy for a lot of stuff, for configuration, deployment, even troubleshooting. Essentially, it's just a number, it's an identifier to identify a particular security association for the particular session. And just quickly, why is a security association, why is it something that's important? Well, if I go back to here, this image, actually not even this image, if I go back here, between a particular network device, let's say 2 routers, let's say this one's in 2 different countries, between these 2 routers, there's going to be multiple IPsec tunnels. It's not just going to be one, is it? You don't buy a router just for one IPsec tunnel. So there's going to be multiple. So how do these 2 maintain and track the connections? How do they track the connections? It's through the SPI. So when an initiator is sending more traffic, he's going to look at what SPI that traffic belongs to. Once he knows what SPI that belongs to, he knows what security association it has. And once he knows what security association he has, and then he can apply, this initiator, he can apply the relevant encryption, the relevant authentication, use the relevant security keys and all them other parameters that I haven't probably mentioned in there. And same with the responder. When he receives some traffic, he knows which security keys to use to decrypt that, because he's going to have multiple security keys for multiple connections. So that's a very important point that I had a moment of epiphany when I realized that, so I thought I'd share that really quickly with you. So if you go back, that's what the security association is, and the SPI is the tracker of that security association, and it's a one-way thing. But yeah, without being bogged down with too much detail, let's go on to step 2. So step 2 is message 3 essentially, and 3 and 4 is the Diffie-Hellman key exchange. So all you should know about the 2 peers, that they're going to use a DH group which are configured on both sides that they negotiated to exchange keying material. So if you don't know what Diffie-Hellman is, then I'd go watch some content on that and go do some reading on that. Essentially, the Diffie-Hellman is used to create a symmetrical key, a symmetric key. So one key that's on both sides. And the symmetrical key is used to encrypt anything that passes through this IKE security association or phase 1 tunnel thereafter. So after the fourth message, after the completion of step 2, you're going to now use this encryption key. So therefore, remember when we said that the last two stages, the last two messages of IKE phase 1 are encrypted? Well, that's why, because we've now determined a symmetric key. Before, we didn't have a symmetric key established, so there was no encryption. So these messages, if you actually go on Wireshark, you can actually see all these messages here, but you won't see these messages because they're encrypted, because of the key is essentially established at the end of message 4. Okay, I'll keep going back, so hopefully it is useful for you. So step 3. So now we're going to message 5 and 6. This last step, the two peers will authenticate with each other using the method that they agreed upon in the negotiation. So remember we said either a pre-shared key or certificate. The initiator and responder prove their identity to each other. So before they move on to the next phase, remember it's going to be IKE phase 2. And that's the actual IPsec tunnel. They want to make sure that who they are, who they're talking to, are who they expect, who they thought that they were talking to. So authentication, that's what it is, isn't it? And authentication. So how it does that is the initiator. So let's just say I configure, let's go with that example that I had before. You configure a password, a pre-shared key on initiator. I'll call it password 123. And what it does, and then I configure the pre-shared key on the responder as well, because I've got to do it on both sides. The initiator at this step will send its identity to the responder along with a hash of the password, which is password 123. When responder gets it, it's going to look at the identity and it looks at the hash, and then it calculates a hash of its own pre-shared key, which is password 123. Then it compares the two hashes. If the two hashes match, that means that the initiator is actually the initiator, and the initiator does the same for the responder. So they've authenticated each other. Of course, it would be much better if they use a digital certificate, which of course has much more verification and validation to it, but just for the sake of this example, they use pre-shared keys to prove their identity to each other. So the authentication in IKE phase 1 is essential because it ensures that both parties are who they claim to be, so preventing potential attackers from impersonating one of the devices in this VPN connection. Additional good stuff to know is I've already explained that part, and IKE uses UDP port 500, but forget about that now. These two messages encrypted are using the shared symmetrical key, obviously, because we've spoken about that also. So moving on to IKE phase 2. This is now the actual IPsec tunnel. So remember, it's the tunnel inside the ISACAMP tunnel, inside the IKE phase 1 tunnel, inside the security association tunnel. So there are quite a few names to it. So I think getting your head around the nomenclature is the first challenge when understanding IPsec. So again, let's do a summary of the IKE phase 2 tunnel. So IKE phase 2 tunnel is used to negotiate the actual IPsec tunnel, the IPsec Security Association per se. There's only one mode to this, which is called quick mode, and it's also just called the IPsec tunnel, which I've mentioned a good number of times. It's the tunnel that's actually used to protect the user data, and all the packets below are encrypted. As we mentioned, that after step 4 in IKE phase 1, we established a symmetrical key. That symmetrical key is going to be used to encrypt all further messages in IPsec. So we've already, all of these messages to establish it are going to be encrypted. And then a single IPsec security negotiation always creates two security associations, one inbound and one outbound. That's one key point to remember. And there are three messages in the IKE Phase 2 tunnel, and we're going to look at each of them. So, the first message. So I've not broken it down into stages because only three messages. Let's just talk about what happens in each one. The initiator sends the sends following security association proposal to responder. Yeah, okay. So it proposes all of these parameters here. So the network engineer is obviously going to configure and configure these with the particular parameters, whatever he's looking for. So IPsec protocol. Let's say the initiator, we've configured ESP. Okay, so it's going to send that to the responder and say, do you agree that we're going to use ESP? Encapsulation mode. Do we use tunnel mode or do we use transport mode? Encryption. What encryption algorithms are we going to use for the actual IPsec tunnel? Yeah, we used DES for the formation and for the management IKE Phase 1 tunnel, but what we're going to use for the actual encryption for going forward? Authentication. What authentication algorithm are we going to use? Are we going to use MD5 or are we going to use SHA? Lifetime, how long should it be valid for before we refresh the keying material? And then optional, you've got the DH exchange, which is used for perfect forward secrecy, which we won't touch upon in this video. So, second message, the responder responds. If the parameters above matches, the responder, obviously they agree, and the responder accepts the proposal and sends it back to the initiator. The final and third message, the initiator sends a confirmation that the IPsec Security Association has been negotiated, and now we can start encrypting all traffic. So thereafter, all traffic will be encrypted. That brings us to the end of the successful creation of an IPsec tunnel. So all that's left now is to start encrypting the data, whichever protocol it chose, whichever protocol you chose. So the IPsec tunnel has now been formed. The data is now encrypted between the initiator and responder, between the two network devices. So that brings us to the end of this video, of this short introduction to IPsec, let's say. Hopefully that was clear. If anything isn't clear, do feel drop a message, drop an email, and I can try to explain it further. If there's anything that I made unclear or didn't explain enough, then please also let me know. In future videos, maybe we can take a look at what authentication header is, what ESP is, what the things are that we didn't really get into much detail of. But yeah, that brings us to the end of the video. Thank you very much for watching, and I'll see you next time.